So what's up guys, welcome back to part 3 of the tutorial series. In the last video we worked on the state machine, and now we're actually working on the light attack. So if I click my left mouse button, I'm going to perform a light attack sequence. It's just a 4-hit combo. If I stop attacking, my state will be resetted and I can attack again. I can also change my direction while attacking. So if I'm moving in whatever direction, my character will slowly rotate in that direction when playing an attack. I've also implemented a bit of like a buffer system. I know I'm using that term probably wrong, but basically what it's doing is that it's shoving the character a bit forward. So every time I attack, I've made this system where the character will get shoved a bit forward a little bit to add a bit of distance. So as you can see, it's quite hard to tell, but it's adding about 10 Unreal Engine units on top of the root motion distance, so it gives a bit of more distance covered when attacking. So if you guys want the project files for yourself, head over to my Patreon and join me there, and you'll get access to all the project files along with a fully commented system. It's more explained there, but I'm still going to explain everything you need to know with the system, how we're going to make it. So let's get started. So welcome back. In the last tutorial video, we set up our finite state machine and we made a basic test. So if I click my left mouse button, I get a print string that says attacked. If I start to spam it, there will be a delay of 1 second before I can attack again, and that's just a system that I made, as in this video we're gonna actually start implementing our light attack. So to start off, let's open up our player character, head into blueprint, open up a character, and we can remove this test code. Next thing I want to do is open our character mesh. We're gonna add a socket so we can attach a weapon to it. So I'm gonna save everything real quick, head over to the right hand and add a socket. Name this weapon socket or whatever socket you want to name it. I'm gonna attach a preview mesh. Search for your weapon mesh. And for the tutorial's sake, I'm actually going to modify the scale within the socket itself. It's not highly recommended. I highly recommend making your own weapon blueprint and modifying the scale from there, but for this tutorial's sake, I'm just going to modify the socket itself. Rotate it in place. Okay, that should do it. We got to test this out by adding a static mesh onto our character mesh and then select our weapon and then attaching it to our socket, new socket that we made. And you can deselect everything and check. Yep, it's looking good. So to start this off, we're gonna need to make an input action. This is only for UE5. If you're using other engine versions, you won't need to do this. You would use the old version of making inputs. But if you're using UE5, I'm going to be using the enhanced input system. So we're going to hit select input action, IA_light attack. Open this up and we're going to add a trigger. And we're going to use pressed. Now with the enhanced system, you can actually make the charged attack by removing this trigger, but I want to use the old way of making charge attacks, so the system can be remade in older Unreal Engine versions. So we need to add our input action into our mapping. Over here, search for light attack, and I'm going to bind this to my left mouse button. Save everything. To get the input event, we're just going to search for the input action name, so IA_light attack. And so first thing we're gonna do is start working on whether or not our player can save our input, and so we can buffer out the attack. Basically, if the character is in the attacking state or playing an attack and we press the input, we want to save that input so the light attack will be buffered out for the next one. So we'll get that quick sequence of animations. To check that, we're just going to check whether or not our character is in the attacking state. So we're going to use our function that we made, is current state equal to any, and we're going to search, make an array. So if the current state is equal to, if the current state is in the attacking state, then we want to save our input, as this means that we are currently attacking and we press the input again, we want to save our input. If we are not, we would want to play an attack. So let's make a Boolean value here, p save light attack. So right here, we're going to save that and mark that true, so we save the input. On false, we're gonna make a custom event here called light attack. We're gonna call the event light attack here. So if So in the light attack custom event, we're actually going to attempt to attack under certain conditions. So first thing we're going to need is a branch. This will govern whether or not we can or cannot perform an attack. So we're going to make a function. So we're going to call this can attack. We're going to make this a pure function, and this function will basically return a value deciding whether or not the player can actually attack. Return value, and we're going to grab our state machine and use this function that we made. So is current state equal to any, we're going to make an array. And so here we're going to select all the states that our character shouldn't be in order for him to attack. So if our character is in the attacking state, we shouldn't be attacking. If our character is in the dodging state, we shouldn't be attacking. And if the character is in dead state, we should not be attacking. So we can reverse this value by grabbing a not boolean, plug that in. So basically, if the character state is in none of these states listed in the array, this value will be true. So we're going to pull this function can attack, plug this in here. So if the player can attack, we would play the attack. So right here, we're going to make another function called perform light attack. So perform light attack, we're going to need an input, call it attack index. Now actually this input is actually optional, but the reason I'm adding this is I'm going to show you how you can possibly use a single variable to govern all the attack indexes. Again, it might need some alterations, as having one variable govern multiple combat systems is going to get very buggy. But if you have this input, it is possible to do it. But I'm just going to keep this input in here. You can, if you want, you make a single variable and use that single variable to govern all the indexes of the multiple combat systems that we're going to make. So we're going to need an input. So let's make another variable called light attack index. And we're going to make another function, variable, call it light attack montages. This will be in a montage, and it's going to be an array. We're gonna compile everything. So right here, we're actually going to do a quick check. What this check will basically do is see if this index is greater than our light attack sequence. So we're gonna get a length here, and then we're going to pull off grade is greater than or equal to, and if our light attack variable is greater than or equal to our length of our light attack sequence, then we want to reset our light attack variable. We're going to reset that, and then off of the grab another light attack, and we're going to get a copy of the light attack based on the light attack index. Get a copy of the animation from the index of our variable. So we're going to check is valid. Is valid. So if it is valid, we're going to promote this to a variable. We're going to promote this to a local variable. And I'm going to use the prefix L underscore light attack montage. The L underscore prefix will just basically help distinguish that this is a local variable. We're going to use an is valid node. And on here, we're just going to use a print string. I'm going to set this to 10 seconds. Give it like a red color so we won't miss it. And then say something like light attack montage invalid. And then we can return here. Now, once we have the light attack, we are going to start preparing ourselves to play the animation. But first, we need to set our state to attacking. Once we set our state, we can actually play the animation. So play anim montage. Now there are two play anim montage nodes. You can get the montage play, which you would have to grab this, the mesh, get anim instance, and then grab montage play. There's also another one where you would get, I think it's called montage. Search up montage real quick. Play montage. So play montage. Let's see, there should be another function here that you can call, which gives you more pins, such as if the animation is finished or completed. It should be around here. It's something around the lines of montage play. Yeah, there it is. Play montage. There it is. So I guess you can't play this from the animation function, but it is available on the event graph, but not in a function. So you have access to this function as well, but since we're actually making this into a function, I don't think that function will work. So we're just going to use this play anim montage node, and most of the functionality will be governed through Anim Notifies. So this work just fine. Just going to get the local light attack variable that we set over here. I'm going to plug that in. Now, after we play the animation, we need to increase our index. So we play the next attack in our light attack sequence. We're just going to make a plus plus. This will increment it. And now we have to do an additional check. And this additional check will determine whether or not we need to reset the reset the index, because if we play the last attack in our sequence and we increase it, we can do an additional check to reset it so we can start back at the beginning of our light attack sequence. Right here, we're going to do a greater than or equal to, and we can copy this section right here. And we can make a branch, plug that in, and if it's true, we set our light attack to 0. At the end, we're just going to return. Nice. Now we're going to call this function here, perform light attack, and we're going to pull our light attack index into here. So let's make ourselves some animation montages and go from there. So we're going to go to this pack here, go to attacks, light attacks. I'm just going to make an anim montage here. So this one will be number 1. Can name this am underscore light attack underscore 1. This one will be number 2. So rename this to am underscore light attack 2. Am underscore light attack. Oh, that's it. This one will be am underscore light open all this up and enable root motion. Enable root motion. So with our current system, we should only be able to play the first attack in our light attack sequence, and that's because we don't have a way to clear this state. And so this Boolean check right here will actually fire in the true pin instead of the false, and so we won't be able to actually play the second, third, or fourth animation montages, as we haven't set up a light attack buffer system yet. So inside the light attack, I'll make some few comments. Awesome, so let's give this a shot. So if I play, and if I click my left mouse button, I'll get invalid. That's because I didn't add it into the variable. Rookie mistake. Let's add some animations here. And so like I mentioned, we should be, with the current system right now, we should only play this first one. These three will never actually play. In fact, we'll only play this first one once if we code the system correctly. So if I click my left button, we play the attack, and now I cannot no longer attack. And if you want to see why your code isn't working, a great debugging tool is by having your code open and pressing this play button here. You'll open up a separate window, and up here in the no debug object selected, if you drop that down and select your character, you can start to see lines of execution with orange lines. So if I start to move, you can see some orange lines with my movement input events. If I let go, all of them will start to disappear. Once I start moving again, the execution pins will start running again. Now if I click my left mouse button once, you see that attack. Now if I try to spam it, you can see that it's currently constantly calling the save light attack event. So can't really play the other animations. So next thing we're going to do is start making that light attack buffer system so we can play the next sequence of the attack. So we're going to make another custom event. Actually, this could just be, we could actually just make a function. So let's do save light attack. That way we don't have to clutter our event graph with unnecessary events. This event could just simply be a large function, but because this functionality in here already is quite messy, I don't want to cram it all in here. So by making it an event, we can actually see the line of execution, so the branches and all the checks before the actual attack. So it's a good coding strategy. Inside the save light attack, we're going to do a branch here. And so in this branch, we're going to check if this is true. If the input was saved, first thing we need to do is actually clear the input. And now the next thing we need to do is just return on the false. Next thing we need to do is another branch. And this branch is going to decide whether or not we should reset the state. Because when coding a large combat system, there's going to be times where the variable is set, even though you don't want it to be set. And so this serves as like a second barrier. So if our current state, we can just plug this in, make an array here. And in this array, we only want to include the states that our player should be in to buffer out the attack. So if our character is spamming the light attack, he should be in the attacking state. And so if he's in the attacking state, we want to clear the state. So we want to set the state here. So now that the attack is if he's in the attacking state, we just reset the state. If he's not in the attacking state and in some other state where this function is called, then we shouldn't reset the state. And by not resetting the state, it shouldn't cause the character to play an attack unless that state allows the player to do so. So right after playing this, we call light attack, which is our event. So whether or not we reset the state or not, we're still going to attempt to play an attack. So So now we are going to make an Anim Notify to call this function at a specific time in an animation. So let's head back over to our blueprint folder, make another folder called Anim Notify, make a blueprint class, and in the drop down we're going to search Anim Notify, and we're going to call this an_save light attack. You can call this whatever you want. Just going to call it that simple function so we know what function is going to be called. On receive notify, which is a function override. On the mesh component, we're going to get owner. And then right here, we're going to cast to our play character. So pp_character. And then we're going to call our save light attack function. And then we're going to reset this state. Make sure this return value is true. I found that keeping it true might help. Sometimes it doesn't, sometimes it does. Regardless, just keep it safe. It's better safe than sorry. So right here, we're going to add our save light attack. So during the recovery animations, we should be able to buffer out of the attack. So right around here. Pick this one, it's about right here. This one is going to be about right here. And for the last attack in your light attack sequence, it should be a bit further out, as we shouldn't be able to, unless you want it closer. But typically, if you reach the end of your light attack sequence, there's a longer delay before you can start back your light attack sequence. So just keeping it a bit further away will help. So now we should be able to play throughout our entire light attack sequence. So if we give that a try, and that's not working. Why? If we increase, hold on. That should be it. There it is. That bit of a code in the beginning was the reason why it didn't work, because the math here was a bit wrong. It's if the index is greater than or equal to the length. It's not if the length is greater than or equal to the index. So right here, if we give it a try, we should be able to play through our entire light attack sequence, but once we stop, we won't be able to attack again. That's because our state is still in the attacking state and we haven't cleared it. So our next part is going to be making a reset state event. So custom event. Why do I need this event? It should be reset state. And so this function right here will evidently reset our states and variables and allow our player to perform another action without having like a saved event to buffer it out. So basically, if our character does nothing, we should be able to perform anything. So right here, we're going to clear our state. And then we're going to make another function for our light attack. It's going to call reset light attack. And this function will be very simple. It'll clear this variable and I'll reset our index. Very, very simple. And we're going to call this function as well right here. So during reset state, we should set clear state and reset light attack. So we are going to need another Anim Notify, so we're going to duplicate this and call it AN_reset_state. And we're going to call our reset state event. And once we compile, we're going to need to add this event to near the end of our animation. So right here, once we are almost close to the idle pose, we can reset our state. So reset state right around here. Reset state right around here. Reset state right around there. So now if we give this a shot, we can go through our entire light attack sequence, but once we stop, we should be able to attack again. And as you can see, that works just fine. Now, one thing I want to point out with this light attack buffer system is that it only calls once. So during this start animation, so this is my first attack, between this start of the animation and to the Anim Notify, I have to press my left mouse button in order to save the input. If I were to press the input around like after the notify, then my next combo attack will not play. That's because this save light attack function is not being called. Now you could make a AnomNotifyState. So let me show you. If I go to my blueprints, we can make another class called AnomNotifyState. Notify state right here. And we're called ANS_resets save light attack. Save attack. So in this function, we're gonna use the onReceive_tick. We're basically just gonna copy this functionality over. So on a mesh, if it is valid, call the function. So now if I add this, so if I delete this old one and add this notify state, so right around here and around here, all the way towards near the end. So basically, not only do I have all of this time to save the input, I also have all of this time. So basically from the start all the way to the reset state, I have all that time to click my mouse button again to save the input and play the next attack. I found that this is a more preferable way of handling light attack buffers or any type of buffer, as it gives the player more time to actually hit the button and save the attack. So we don't have to wait for we don't have to click the mouse button here. We can click it all the way till we reach the end of the reset state. It's also okay to actually extend this a little bit, just so that if like it's on the reset state but it's not quite at the reset state, we can still buffer our attack. It's a more preferred way, and it's going to be the way I'm going to keep it, but you have the other way of doing it as well. The only issue with this system is that it's playing by the tick, so you're constantly spamming this function call, which typically is never good. This is why I kind of avoided this type of system, but there can be some workarounds around it. But if you're that advanced and you know what you're doing, you're more than welcome to modify the system to fit your needs. But I'm gonna keep this quite simple. We're gonna do either a tick function, so you can call this function by the tick, or you can call it by a single fire. Totally up to you. Right around here. So now if I play the animation, if I play the attack, during the recovery frames, I can attack again. So see, quite delaying it quite a bit, and I'm still able to perform through the entire attack, which is great. Now we can actually improve this system a little bit. Some things that are cool about Anim montages is that they have a blend in and blend out. So basically it blends from one animation to another. So if your animations aren't perfectly aligned, the blend in blend out will help make it look more like it blends in really well. So by lowering this, we can actually have our player snap into the attacks. It doesn't sound good, but it definitely feels and looks good. We can also change the rate scale so the animations are quicker. can lower this down. I'm gonna try to set everything to 0.1. Maybe on the last attack, I'm gonna keep this at 0.25, but the blend in, could definitely make that faster. The thrust seems to be okay. The speed on that seems to be okay, so we don't need to change anything there. Here, do 0.1 for everything, and we can give that a go. As you can see, it's a lot more responsive. The attacks feel a whole lot nicer. So those values you can tweak however you like. The blend in and blend out functionalities are really cool. I really like them. Really helps you make some unique movesets with animations that don't align well with each other. So the next thing we're gonna do is work on a system where players can rotate their character depending on whatever direction the character is moving in. So as you can see, when I play in the editor and I'm trying to move, I'm kind of locked in that position because of the root motion. But there's a variable you can actually modify in the character to allow rotation while playing root motion. So we're gonna actually make that system here. We're gonna make a new AnomNotifyState. So AnomNotifyState. Call this ANS allow rotation on root motion. And so we're gonna grab the receive notify begin. And so the begin gets fired once at the beginning of the notify, and then we have another called end, which fires at the end of the notify. And we're gonna need both. Start this off, we're gonna get owner. We're gonna cast our character. And then after casting, we need to get our character movement. Right here, and there's a variable that says something about root motion. So allow rotation, physics rotation, set allow physics rotation during anim root motion. I think that's the one, so we're gonna check that on the beginning. So on the receive begin, we're gonna make that true, and then on the false, we're gonna set that to false. So we can actually copy all of this as it's the exact same thing, just one variable change. We're gonna set this to false. Plug this at the very end. And then plug this over here. Now if we head into our attack, well, forgot to plug this here. There you go. So now if we open up some of our attacks and add them in, we should be able to rotate our character while playing the root motion. So I'll make another track. It's in the state. And so for here, we're just gonna do it like a bit during the anticipation frames. So maybe a bit right after he steps. So right here, once he lands his step, as you can see, he steps a little bit forward. During that time, we should be able to rotate. Same with the other animations. We're gonna do the same exact thing. So right when his foot lands, right around here, lands right around there. Here, kind of a bit of a spin. So maybe here you might want to find a place where before he swings his sword. So maybe right around here. For the thrust, same thing. He maybe sometime before the impact frames. So maybe right around here should be good. So this should allow us to rotate our character while we play the root motion animation. So as you can see, as I'm moving, the character rotates in the direction of my movement. So I can move forward, I can attack backwards, left, right. So the character slowly rotates towards that direction so it doesn't feel super snappy. You can actually increase the speed at what it's rotating by going to the character movement and search for rotation. And right here, the rotation rate is at 500. You can increase this and makes it more snappy, but the rotation rate is basically how my character slowly rotates from left to right. As you can see, my character is kind of rotating into the direction before running in that direction. Same idea. That's basically what this rotation rate does, and we're using that rotation rate to drive that physics on the root motion. So I can still move around. And now the last thing I want to add in this video, it's been quite long, bear with me, is a system where I can add additional distance to the root motion. So if I add a custom event here, add movement or something, maybe like add movement, sure. Doesn't really make a whole lot of sense. In the last tutorial series I made it like a light attack buffer or something, and I never knew what the word buffer meant. Just buffer made more sense to me, so I'm just gonna call it attack buffer. Probably the wrong term to use, wrong word, but it makes the most sense to me. Probably not to you, so use what you need. Next thing we're gonna do is make a timeline. Now timelines are quite useful as it generates a value along a time. So unlike the tick, the timelines run for a certain amount of time. The tick runs constantly, forever. But a timeline can be easily controlled as it only runs for a certain amount of time, plus it generates us a useful value. The delta time from the tick event can be useful when you want some functionalities to be frame dependent, but very not much use for the tick event. I find the timeline a lot more useful for certain things. So right here we're gonna have the attack buffer play from start, and basically what we're gonna do is we're gonna drop this length to maybe like 0.5. It's going to be quite quick, maybe like 0.6, maybe just keep it at 1 second. So if you hold shift and you click, you can make keys. For our first key we're going to make it 0 0. For our second key it's going to be 1 1, and so as the timeline plays it starts at 0 and that value constantly goes up until it reaches 1 1. Similar to how graphs work in math, if you really like math or want to think it that way. You can change this name here, let's just call it alpha. And so what we're gonna do is we're gonna push our character forward by a value, by like a distance multiplied by this alpha. So first thing we're gonna do is we're just gonna grab a set actor location. Now we want sweeping enabled. This will make sure that we won't clip through walls or whatever. But the big issue with this is that we actually constantly, if we do collide with something, we constantly generate a hit result, which isn't good either. But I feel like the gain overweighs the cost here. But if you guys find another way, better way, feel free to share it with me. I'm more than happy to try it out and maybe make an update on this. But for now, we're gonna grab our character location, so get actor location. We're also gonna get our forward vector, get actor forward vector, and we're gonna multiply our forward vector by a value. As our forward vector has a magnitude of 1, we need to multiply by another value and add that onto our location to actually get like a direction and a distance. So I guess you can say the forward vector serves as a distance. The multiplication here, what we're doing is going to be the distance, and then this location will help us get it to where the player is. So direction times distance, and then add that to the location. So right here we're gonna make like maybe we can actually just make this into here. We're gonna make it an input and we're gonna call this distance. Inputs, we're gonna call this distance. So we can just rename this to buffer, as we can use this for multiple things as long as we give it an input. So right here, not equal to 0, not equal to 0, we should play. If it is, we stop. Actually, we shouldn't be stopping yet, as some functionalities should be still running. Let's not jump to conclusions yet. Reroute node, pull that down. I like my nodes clean. There you go. And now we have to add that to the location. And we're gonna need a lerp. Now I'm gonna try the lerp first. I'm not sure how that will look. The lerp will basically move from point A to point B, given an alpha. There's another one, it's vinterp, which also runs on delta time, so it's frame independent. Right here, we're gonna make a v lerp vector. I'm gonna try the lerp first. I found that I like lerp a lot, so maybe we could get away with using lerp. If not, we could just revert back to this. So let's call that function here right before you play the attack. Actually, you can call that in the function. So right before you play the attack. So after we set the state, we should buffer. And for testing purposes, let's give it like a large value of 50. See that it actually works. We can tweak the values and we can tweak the distance later. Right here, for the attack. As you can see, we are moving quite a lot. So the time here, we should decrease that to maybe like 0.1. I feel like that's very short, but we can tweak that later again. So let's give that one more shot. Okay, so it's working, but it's moving very fast. So maybe let's bump that up to 0.25. Again, you can tweak these values however you want. Okay, kind of like that. Okay, I kind of like 0.25 right now. Now we can actually decrease the distance here. So let's say 10. And one more thing. We need another function here that says stop. Stop buffer. So whenever we play, before we ever play, we should always stop the buffer. So right here, if we ever try to play a buffer and the buffer system or the timeline is still running, we should always stop it, do the check, and then attempt to play it. That's one way to actually help control your timelines, is making sure you always stop when you don't need them and always play when you do. And so that reminds me, we should always stop buffer. So not stop audio bus, stop buffer. So we should always, on the reset state, we should always stop any timeline that we are running unless they are absolutely needed. So we can get away with the lerp node. So let's give this one more go. Make a reroute node here. So right here, as you can see, there's a slight bit of push here. So it helps us give a bit of distance along with the root motion. So the character got some distance from the root motion itself, but with this buffer system, we can add additional distance to it. And as you can see, with that little bit of distance of 10, it almost looks like there's nothing there. Like, you can't really tell that I'm adding a buffer. But as you can see, I'm covering a huge amount of distance. I have, with just like 2 sequence of attacks, I'm nearly all the way to that wall, which is a really cool system. Hope you guys enjoy this, because I made this one myself. There's not much videos for the buffer system like this. So with all of that done, I think we've laid some pretty solid groundwork with our light attack system. You guys can definitely improve this, make it like a 5 combo attack for your light attack. Modify the timeline, modify the animation blend-ins, do whatever you need with this system. We're gonna keep expanding it with the next video going to be about our heavy attacks. So with all that said and done, see you in the next one. Hope you guys enjoy what I've made today.